this symbol right here, this is called a radical. That's what that symbol's called. It tells us to take the square root. You might have just called it a square root sign in the past. It's got a cool name. It's called a radical. Okay, so when we talk about simplifying radicals, we're talking about simplifying square roots. Okay, now, if I take the square root of a perfect square, I get a whole number. We've talked about this already. Okay, so like the square root of 64, that's 8, because 8 times 8 is 64, right? If I wanted to draw a square that has an area of 64, I would draw a square with a side length of 8. Same deal with 100. That's a perfect square. It's 10, right? 10 times 10 is 100. 3 times 3 is 9. 12 times 12 is 144. And 1 times 1 is 1. These numbers in here, 64, 100, 9, 144, 1, those are all perfect squares. And we get nice whole numbers. Now, if we want to take the square root of a number like 80, okay, that is not a perfect square. So we need some new strategies, okay? Now, you can put this in your calculator and you can get a decimal. The thing is the decimal actually goes on forever and it's not actually an exact number. So if we want an exact number, here's what we do, okay? We first prime factor, okay? Now this you know, this is not new, okay? So I'm just gonna go ahead, I'm gonna do step 1 right now. So I'm gonna find the prime factorization of 80. Okay, so I realize 80 is gonna be 10 times 8. 8 is 2. Notice I'm circling. Okay, I'm always circling when I get to prime numbers. This is super important. It's going to continue to be important. Okay, and 10 is 5 times 2. Okay, so here's what I notice. And watch when I write the factors. I'm going to make sure that I put all the 2's together, right? So I'm not going to put like 2 times 2 times 5 times 2 times 2. I'm going to put all the 2's here. Okay, so basically, the prime factorization of 80 is this. 2 times 2 times 2 times 2 times 5. Okay, now, that is still all under this square root sign, right? So I've done that. I've prime factored. Okay, that's step 1. Okay, so we're ready for step 2. Okay, here's step 2. You're going to separate out doubles. Oof, that is not how you spell doubles. Oh boy. Separate doubles, and you're going to simplify them. What does this mean? Here's what it means. See how I have 2 2's? I'm going to separate them. I'm going to put them in their own little radical sign. Here's another pair of 2's. I'm going to separate those guys, put them in their own little house, right? Now this guy, not a double, I'm going to leave it in this original radical sign. Okay, so notice if I had doubles, I pulled them out. Now, here's the thing. See this right here? This is 2 times 2. That's 4, right? And then there's a radical sign. There's a square root sign. So what's the square root of 4? Well, the square root of 4 is just 2, right? This is just all this. That's just the number 2, right? And you can think of it a couple ways. You could say, okay, 2 times 2 is 4, and the square root of 4 is 2. You could do it that way. You could also think, okay, this is basically 2 squared, and then the square root. Well, squared and square root are inverse operations. They undo each other. So if I take 2 and I square it and I square root it, I just end up with 2. Same deal here. This just equals 2. So all of this is being multiplied together, right? This is just, all of this is multiplied. This is all multiplied. So this becomes 2 times 2 times, can I take the square root of 5? That one's going to be a decimal. And here's the thing. It's actually going to be like a non-ending, non-repeating decimal, and we just don't like those numbers. They're called irrational numbers, and we really don't like dealing with them. So we don't. We just kind of leave this guy in there. Okay? And so once I've separated the doubles and I've simplified the doubles, right? Notice this is still in a square root. This is not. These are just regular old numbers. Okay? And the final thing we're going to do is we're going to multiply, if needed, sometimes we don't need to, on both the inside and the outside. What does that mean? So here, in this case, I have 2 numbers on the outside of my radical sign. I'm going to multiply them together. This is 2 times 2. This is 4. In this case, I don't have 2 numbers on the inside of my radical sign, so I don't need to multiply. And this is my answer. This is called 4 root 5. 4 times the square root of 5. Okay, and in Edulastic, you'll just literally type it as 4 and a square root sign and 5 on the inside. Okay, but this is, what's this same number, it's simplified. Okay, and this simplified form turns out to be really important for a lot of things. Okay, so I've simplified the square root of 80. Following these steps, I'm going to do the same for 450. Okay, and I'm going to write a little bit smaller on this one so I have more space. I have a little tight on space on this one. I see right away I have a 0 on the end, so I'm going to think, okay, well, that's divided by 10, and my other factor is 45. 10 factors right into 2 and 5. And 45, I think, okay, that's 5 times 9. And 9 is 3 and 3. So I'm going to write out my factors. And again, watch when I write, I'm going to be careful to write the doubles together. And in fact, what I'm going to do, I notice there's a double 5 and a double 3. And there's a single 2. I'm going to put the 2 at the end, right? Because you can kind of see it sort of worked out for me that the single number was at the end here. So I'm going to do that same thing. So I'm going to write 3 times 3 times 5 times 5 times 2. Now remember, that's all under the radical sign. So I'm going to separate out the doubles. Right, this double, I'm separating it. This double, I'm separating it. And that 2 is just going to stay by itself because it doesn't have a partner. Okay, so this is 3 times 3, that's 9, and the square root of 9 is 3. This is 5 times 5, that's 25, and the square root of 25 is 5. And this root 2, it just stays root 2. And then I'm going to multiply, right? In this case, I have a 3 and a 5 on the outside. This is 3 times 5. And the 2 doesn't get multiplied by anything on the inside. Okay, now in both my examples, I had 2 numbers on the outside and I only had 1 on the inside. Sometimes you'll end up with more than 1 number on the inside and then you'll multiply those together as well. Okay, but here, these are my 2 answers. So now it's your turn to try this out. Okay, go ahead and try those 3.